Everyone, today I am going to discuss regarding software quality and McCall's quality factors of software engineering. The software quality and the effort to understand it in terms of measurable qualities date back to the mid 1970s. McCall, Richard, and Walter were the first to study the concept of software quality in terms of quality factors and quality criteria. Usually, a quality factor represents a behavioral characteristics of a system. Some examples of high-level quality factors are correctness, reliability, efficiency, testability, maintainability, and reusability. A quality criteria is an attribute of a quality factor that is related to software development. For example, modularity is an attribute of the architecture of a software system. Highly modular software allows designers to put cohesive components in one module, thereby improving the maintainability of the system. Now, software quality is a degree of which a system components and process meets the system requirements. In other words, software quality is users' satisfaction. The word quality is a complex concept. It means different things to different people and it is highly context dependent. Thus, actually, the software quality, if we say, if it meets all the users' criteria, if it can be used to solve all the user criteria, then that can be treated as a qualitative software or a system. The software quality is difficult to define. Thus, it depends on some viewpoints of the observer. Okay. Now, coming to the viewpoints, here are some views. First of all, there is transcendental view. It visualizes quality as something that can be recognized but is difficult to define. The transcendental view is not specific to software quality alone, but has been applied in other complex area of everyday life. Now, according to user's view, it perceives quality as fitness or purpose. According to this view, while evaluating the quality of a product, one must ask the key question: does the product satisfy user needs and expectations? That means it will check how, whether the system can fulfill all the criteria given by the uh, customer or the client, and if it can fulfill all the criteria given by the customer, then it can be treated as a qualitative software or a system. Okay. Now, the next one is manufacturing view. Here, quality is understood as conformance to the specification. The quality level of a product is determined by the extent to which the product meets its specifications. Means whether the product is developed according to its specifications or designs or not, that will be checked. So it should be actually whenever it will be developed or the manufactured, it should maintain the design and the specification given by the designer team. Okay, so that is manufacturing view. The next one is product view. In this case, quality is viewed as coupled to the inherent characteristics of the product. A product inherent characteristic, that is internal qualities, determines its external qualities. That means if the product is good from inside, it will be good in outside too. That is the product view. Okay, next one is the value based view. Quality in this perspective depends on the amount a customer is willing to pay for it. That means whenever a customer or a client give order to the software company to develop a product, There, as much as the customer can pay to the company, that much qualitative software will be developed for them by the software development team. Just like, suppose if anyone wants to buy a car for a specific model, okay, that model can have various facilities. So if you pay more, you will get more facility. So maybe the base model is can be purchased in rupees 5,000, okay. And suppose if you pay some more bucks, you will get AC. If you pay more bucks, you will get music system. If you pay more bucks, you will get power window, power steering, and so on. So that is value based view. If you pay more, you will get more, right? Okay, the next one is uh, the main topic of our discussion today, that is McCall's quality factor. Quality factors represent a behavioral characteristics of a system. Okay, now the software industry have been anxiously targeted for improve the product quality with innovative methods. Software quality plays the vital role in the software development in the various phases of the software development lifecycle. The faulty software products has significant cost to the suppliers and unsatisfaction to end users, which fails to meet their goals. Any system behavioral characteristic represent quality factors. The Jim McCall developed the model for US Air Force, identified with three main perspectives for characterizing the quality attributes of software product. Okay, and these three main perspectives are product operation, product revision, and product transition. Okay, now under product operation there are uh, five key factors. Those are correctness, usability, reliability, efficiency, and integrity. Under product revision, there are maintainability, flexibility, and testability. Under product transition, there are portability, reusability, and interoperability. We'll come to these factors one by one in this video. So here the three perspectives. First of all, there is product operation. The product operational characteristics show the operational behavior of the software product, like correctness, reliability, usability, integrity, and efficiency. And if we ask a question, how well the system runs or how well the system executes, then that can be defined by these key factors of the product operation perspective. That means correctness, reliability, usability, integrity, and efficiency. Next, if I ask how well the software can be tested, changed, and redeployed, that is product revision. The product revision is the ability to change, test, and maintain the software product as per change management. Example, testability, flexibility, and maintainability. That means the system is suppose if there is any need, we have to check whether the system um, can be modified itself for that modified needs or modified requirements. If the system can do so, then it can be treated as a qualitative system or a software. The next one is product transition. The product transition have the adaptability and comfortability features with the new environment. Examples, interoperability, portability, and reusability. Okay, and if I ask how the system can be moved to different platforms and interface with other system. Then we'll get the answer. Like this product transition, that means whether it can adopt a new system or in a new hardware software environment or not, that can be checked. Okay, and if it can do so, if the system can do so, then it can be treated as a qualitative software, right? The Now, the first key factor for the product operation is correctness. If you go for the definition, um, it is the extent to which a program satisfies its specifications and fulfills the user's mission objectives. A software system is expected to meet the explicitly specified functional requirements and the implicitly expected non-functional requirements. If a software system satisfies all the functional requirements, the system is said to be correct. That means if it can run in all the situation, okay, and if it can run according to the specification, okay, and the design by the software design team, then it can be treated as a correct software. Okay, now reliability. So what is reliability? The extent to which a program can be expected to perform its intended function with required precision. Customer may still consider an incorrect system to be reliable sorry, if the failure rate is very small and it does not adversely affect their mission objectives. Reliability is a customer's perception, and an incorrect software can still be considered to be reliable. That means for reliable to be reliable software or system, it is not mandatory to be correct 100%. Okay, so with some limited flaw, the customer can treat the software as a reliable software. The next one is efficiency. Amount of computing resources and code required by a program to perform a function. Efficiency concerns to what extent a software system utilizes resources such as computing power, memory, disk space, communication bandwidth, and energy. The software system must utilize as little resources as possible to perform its functionalities. Now, what is efficiency? Suppose I'm giving you 5,000 rupees, and suppose you have 5,000 rupees and you have to go to Mumbai from Kolkata. You can buy, one option is you can buy a flight ticket by which you can go from Kolkata to Mumbai within 2 hours or 3 hours. Okay, and there is another option. You have a bicycle, you just buy a second-hand bicycle within rupees 5,000 and start paddling and reach Mumbai in a few days. Okay, where you have to spend some money for your food, fooding and lodging. Okay, even you have 5,000 rupees, so you can spend it as you want. So which will be more efficient, by the flight or by the bicycle? Okay, obviously by the flight, because you are spending the same money to go to Mumbai, but it will take less time, less effort, okay, and more comfortable. So like that, the efficiency of a software system depending on various things like this: power, memory, disk space, communication bandwidth, and energy, right? Next one is integrity. The extent to which access to software or data by unauthorized persons can be controlled. A system integrity refers to its ability to withstand attacks to its security. In other words, integrity refers to the extent to which access to software or data by unauthorized persons or program can be controlled. Okay, so that is integrity. Next one is the usability. How user friendly the software is, that can be checked in this thing, in this factor, usability. Okay, the effort required to learn, operate, prepare, input and interpret output of a program. A software is considered to be usable if human users find it easily to use. Without a good user interface, a software system may fizzle out even if it possesses many desired qualities. Just like that, the Windows operating system is more user friendly than the Unix or Linux operating system. Okay, right? So the most of the users, novice users, are using Windows. Okay, because it is more user friendly. Like, next one is maintainability. Effort required to locate and fix a defect in an operational program. So, maintenance refers to the upkeep of products in response to deterioration of their components due to continuous use of the product. Maintenance refers to how easily and inexpensively the maintenance tasks can be performed. The software products, there are three categories of maintenance activities: corrective, adaptive, and perfective maintenance. Now, what is maintenance? Suppose you have a problem in your PC, or if in any product you have, okay, you call the maintenance guy. Okay, if it is easy to detect the error, obviously the error can be rectified, or the problem can be solved that much easily. Okay, so, and that is the maintainability. Easy to detect, easy to maintain. Okay, easy to detect, easy to solve, so it is easy to maintain. And if the maintainability is high for a system, then that can be treated also as a qualitative software, right? The next one is testability. The effort required to test a program to ensure that it performs its intended functions. Testability means the ability to verify requirements. At every stage of software development, it is necessary to consider the testability aspect of a product. To make a product testable, designers may have to instrument a design with functionalities not available to the customer. So it should be easy to test. Your design should be in that manner, by which the testing team can test the software very quickly and easily. Next one is flexibility. Effort required to modify an operational program. Flexibility is reflected in the cost of modifying an operational system. In order to measure the flexibility of a system, one has to find an answer to the question: how easily can one add a new feature to a system? That means if there is any requirement, the software or the system should adopt that quality, I mean that specification into it. Okay, so that will be considered as a flexible software. Next one is portability. Effort required to transfer a program from one hardware and software environment to another. Portability of a software system refers to how easily it can be adapted to run in a different execution environment. And portability gives customer an option to easily move from one execution environment to another to best utilize emerging technologies in furthering their business. So that is portable. Okay, so from one hardware software environment to another, that is portable. Next one is reusability, extent to which uh, parts of a software system can be reused in another application. Reusability means if a significant portion of one product can be reused, maybe with minor modifications in another product. Reusability saves the cost and time to develop and test the component being reused. Means, suppose you have a system and you need to change a little bit to the system, we will not go for buying a new product. Rather, we'll check whether with the previous old system, uh, the new things can be added or not. if it can be added, then that will be reusable. Okay, so reusability is also a feature of quality factor, right? The next one is interoperability, effort required to couple one system into another. Interoperability means whether or not the output of one system is acceptable as input to another system. How likely is it that is the two systems run on different computers interconnected by networks? An example of interoperability is the ability to roam from one cellular phone network in one country to another cellular network in another country. Okay, this is a very good example by which we can understand what is interoperability. So these are the key features of McCall's quality factors. Okay, now if you have any question regarding this, you can ask me in the comment section. I will try to answer all the questions. Okay, in my next video, I will discuss some new things. Okay, till then, goodbye.